Good morning, boys and girls. Welcome to the eastern wing of the Stinkbug Works. Well, I just watched Big B's video, and Big B is 90% right. He has a couple of terms mixed up, and this is an area where he hasn't gone before, so this is not a dig. This is not, I'm just going to enhance what he said. First of all, bearings take radial and axial loads. A radial load on a bearing is the load that occurs along a radial line from the bearing. So there's, 360 radial lines coming. Actually, there's a disc, but I digress. But so any load this way is radial. So as the shaft wants to vibrate and stuff, those are radial loads that the bearing takes. Axial loads are this way. These bearings take up no axial loads whatsoever because the shaft slips in them. There are other bearings that will take up axial loads by means of putting a clip or a shoulder on the shaft, and that way the bearing is held in a fixture of some sort, and that way it can take radial loads. Most ball bearings are designed for primarily axial loads. That's why they slide. And on your motor's end bell is a ball bearing that's designed for radial loads. It's not really designed for axial loads. It'll carry them up to a point. It'll carry far bigger loads in an axial or a radial configuration than in an axial. See, that goes along the axis of the bearing, and that goes along the radius of the bearing. Get it? Axial, radial. So anyway, a ball bearing will work in an axial load up to a point. They're not really designed for it, and that's why scientists and engineers have developed thrust bearings. And Big B showed you a picture of a thrust bearing. Here's the deal, and Big B hasn't done this before. Trust me, I did it 20 years ago. You really don't need any bearings here if you set it up in such a way that the drive dog will never contact the strut during a cable shortening maneuver. When you put a lot of loads on a shaft, a flex shaft, because of the way it's built, it's going to shorten up. And so that's why you leave a gap. If that's where that half the shaft diameter business came from that he talked about. That's to be extra special careful when you have a long shaft and the prop comes out of the water and spins up and hits the water and the prop shaft compresses real quick. Half the cable diameter should take that up without having the drive dog contact the strut. If the drive dog contacts the strut, and here's the problem, Big B's trying to set him up with just a few thousandths between them. And yeah, that will work, but you still got to have a ball thrust bearing between the coupler and the motor case. And I'll tell you why. You want the motor case to carry the load. It eventually does when you don't have anything like that because the loads go through the rotor to the end bell, and that that bearing and spacer shaft he talked about, and then the end bell pulls the motor forward rather than having the thrust bearing push the motor forward, and eventually the motor mount and the hull carry that load, and it's that load that causes the hull to move forward. Does that all make sense? So in low power situations like I run, I can get away with washers in here and let it take up the loads because, it's all low power stuff. Once you start getting into the bigger stuff, I wouldn't rely too much on this. I tell you what, I've seen those bearings for $5.95 plus $5.95 shipping, $12. So, and I've got a box full of them. I should bring them out and show them to you. maybe when I jet out, I'll come back and I'll say, look, here's a box of thrust washers or thrust bearings. So anyway, when you're getting into bigger power, especially when you're getting into bigger power, the best thing is to put all the thrust loads on the motor case and let the cable stretch and shrink as it wants and never, ever, ever, ever let it touch the strut. And you can figure that out mechanically. You can set it up kind of tight and go out and do a run. And if you see it's contacting it at some time, you can stretch it out a little bit. The best way to do it is mark it up with a felt pen and then see if the drive, mark the very end of the strut with a felt pen and see if the drive dog contacts it. You see how much gap I've got here? I've only got a couple of thousandths. But again, this is a low power setup and I'm running that much cable. So there's not going to be much shortening when I have that much cable. When you have that much cable, like your bigger models, that's when you're going to see cable shortening. So enough of that. Now, back to our regularly sponsored video. This is now 100% seaworthy. The only thing missing is a little snap pin for here. So in the interim, I use a piece of, what is this? This is 41 thousandths aviation safety wire. Voila. Look at him, boys and girls. I got a boatload. I got a boatload of foam. So I've crammed foam in there. Most of this is loose. I did glue this piece down so it would always have a little room for the servo to actuate so it wouldn't crash on the servo. I just glued it down with rubber cement. So you can always peel it off and rub the rubber cement away, and it's like it never was there. And it was the same thing with the receiver. I put a shrink tube on it, just enough to cover it, and glued it on there with a big old wad of rubber cement. So there you go. I have my little blue. Turns out I used that on this boat right here. I did the same thing on that boat. Didn't even think about it, but I opened up that boat, and so anyway, that boat's out there because this boat is done. D-U-N, done. It's ready to throw in the water. It balances in the same place the original did. How about that, huh? It's done. And now we get back to the real project, because now I have a new motor, a 705 1Y, 1.5Y, I'm sorry. This thing is, it's like 8435 kV it's going to sing. And, being so small, it can sing. And here's what I'm thinking. The motor mount, the gear drive is going to be the motor mount, and the gear drive is going to be just glued into here, and it's going to be a carbon fiber arrangement, and it's going to be basically just a plate that holds this motor with a slot for it to, a smile cut slot for it to swing in. And then a carbon fiber shaft, and I'll have to have some way of anchoring the end of the shaft. So this will probably be, it'll be one of these flat plates with this bolted to it, boom. And the carbon fiber tube, coming off of it thusly. The thing is, I'm going to have to mount it at an angle. And that's where all the thinking and stuff starts. You got to mount it at an angle. And here's the problem. This motor tucks in here just fine right now. But as soon as I angle it, as soon as the angle of dangle approaches the heat of the meat, it crashes. So the motor has to be within the confines of this, which means roughly, a little more than double the overhang here away. So I always like mounting in my driveline off-centered if I can. If I center it, that's going to push the motor off to the edge. So I'm going to have to off-center the motor, which means if I offset the shaft to the right, the normal way, I'm going to have to run the motor on the left. Now, can I get away with running the motor on the left? Well, I'll tell you what. This motor is so small and light, and this speed control is darn near the same weight. I'll just put the motor on that side, put the speed control way over on that side. I'll just, the speed control, I'm just going to, again, rubber cement it to this foam. The foam's just loose in there, but I'll rubber cement it. So that's my plan there. I'll make the gearbox face out of this, like I said, and we'll get ready to go. I'm going to use just a little tiny servo, and I'll do the same thing I did on that boat. I'll put some shrink tube on it and just glue it to the bottom of the boat. There you go. Boom. The strut, we've already talked about that. I have a cool little carbon fiber strut. I still need to mill a slot in there for this piece. This piece will get sharpened. It'll get a hole. It'll bolt into this. It'll be glued into the back of the hull here somewhere, and that will be the strut. The rudder is going to be this little guy, and I'll just cut a square hole back in the transom for that little guy, and he'll slide into about, there, and before I put it together, I'll cut off the unnecessary part. Depends on where it winds up going. That, boys and girls, is the next project. It's probably going to take a little longer than that just because of the, I'm going to put a lot more attention to detail than I did with this. This was just a quick and dirty wham bam, thank you ma'am. Until next time, boys and girls, jet out. Look at here, boys and girls, look at here. We're in a little box marked thrust. And check these out. Now I have little thrust bearings. These are like 1/8 inch. And here's another one that's like 1/8 inch. But if I'm running bigger stuff, these are the bearings I'd get. They're one piece. See, look at here. One piece. These are 5mm, I believe. But there you go. That's what I would get. You know, I have my collection of Molly nylons. I have my collection of nylons. This one even has blue grease on it. And I have some little tiny shims as well. But there you go. That's what I highly, when you're running bigger power, this between the coupler and the rotor. So the rotor doesn't move. Wherever that rotor is, that's where it stays. All the loads go through here. So you take the rotor out of the equation with that. You're isolating the rotor. There you go, boys and girls. Oh, here's a part number for one. I just happen to have one in a... Can you read that? I happen to have one in a bag. I don't know how old this thing is. These people may no longer exist. I don't know, the rubber bands feel fairly new. Until next time, boys and girls, jet out.